So my latest project was a web app called MySchool. One of the things that I dealt with and learned a lot about in this project is user authentication, login, sign up, JSON web tokens, password encryption. Basically, you have user login. You can create a new user, or in my case, I'm going to log in as my dummy person, Jane Doe. I think she's actually smart, but that's okay. And you can save online resources that you find. So I can create a new resource, give a title, description, provide a link, and choose a subject. I can look at my saved resources. Here I have subjects that I've created. You can create your own subjects or delete empty subjects or look at all your resources. And then you can either delete your entire account if you're just done with it or log out. So first of all, I decided to deploy my front end and back end separately. Right now I just have a web app, but what if I want to develop a mobile app? Both of those front ends can use the same API. I used Node.js. I just commented it like crazy because it was my first API that I had built, and I want to make sure that if I go back, I know exactly what everything was for and what it does. Along with Node.js, I used express.js. It uses HTTP verbs such as get, post, put or patch, and delete, among others. I have post, delete, get, and then these are the endpoints. And typically, this is where you would handle the requests. In this case, I have the logic separated out into other files. Once again, having that file separation organization helps with scalability, right? If a app becomes bigger and bigger, the better organized it is, the less of a headache it will be. So go into the user's controller, and here is the user sign up controller. So the user is going to put in an email and a password on the client side and send that with a request. So the first thing that's going to happen is you're going to see if there's already an email that matches it. And if so, you're going to say, email already exists, try again. If not, what's going to happen is it's going to take the password and encrypt it using Bcrypt. The way that Bcrypt works is it takes all the different characters in the password and encrypts it in a certain way. And then it also adds salting, which is a bunch of like random characters that also get encrypted. So it just ends up as a jumbled mess, basically, that only Bcrypt can translate. And you can specify how many random characters. In this case, I did 10. And if it doesn't work, you get an error. There's error handling for every single request, just in case something goes wrong. Otherwise, you create a new user. Now, what is this? Where does this new user come from? This comes from a Mongoose schema. Now, for the database, I used MongoDB. The pro is that it's easy to work with and it's very flexible, but the con is actually that it's a little too flexible. So, for example, you can create users that have totally different properties, which on the front end will be very confusing. So here's where I create my Mongoose schema for users. Every user, because of this schema, is going to have an ID, first name, last name, email, and password. And for each property, I can say what type it is, whether it's required, and anything else. Like, for example, email, it has to match this regular expression. So that's one way that Mongoose helps. Another way that Mongoose helps is by creating relationships. Now for my app, I wanted a relationship between a user and the subjects and resources that user creates. So like if I delete the whole user, I also want to delete any subjects or resources that that user created. So basically what happened, let's look at subject, is within the subject schema and resource schema as well, I created a reference to the user. So that's one way to get around MongoDB being non-tabular, non-relational, is by using Mongoose to create schemas and relationships through references. Okay, so with that in place, now we understand that when you're creating a user based on this Mongoose schema, right? So it's going to have consistent properties that are sent back. You save it, and then something else happens. you create a JSON web token. The user can then store that web token and use it and send it back in the request headers to basically to say, hey, I have a valid token. I have permission to access this API and these endpoints. So send me the data. So a web token is created and it's sent with the response. Now here is the actual response that the client will receive, message, the token, and user with all the user information. And that's the data I'm going to have to work with on the front end for my app. Otherwise, you get an error if something went wrong. Oh, and here's another error. Just need errors for everything, just in case. Now, along with that web token, there's a middleware that I created to check whether it's valid, a valid token. And the place I use this check auth middleware is in the protected routes. All of the subject and resources routes have this check auth middleware included to make sure that you have access to it. So let's go into the front end now. And I use my typical React and Redux pairing. And one reason I love that pairing is, once again, for the flexibility and scalability. So here I have two files, one for my Redux store, one for components. And each component has its own folder with JS file and CSS file, just for organizational purposes. But I'm going to focus on the store here. So here I have the API URL from my deployed Heroku app. I'm going to use that in each of my API requests. So for user login, the first thing that happens is I'm going to dispatch an action login request. Every single API call, I'm going to have 3 different actions: login request, login success, login failure. So for a login request, for example, it says loading to true, error to null, in case there was an error. Looking at the app, let's do the wrong password, okay? So what happened, you saw the spinner there, that's when it was loading, and this is what happened with login failure. So that's the first thing that happens, login request. Then I make the API call. It's a post request. You use the API URL and then the endpoints, and then user info, which it was sent here from the login form, is sent with a request body. Then we get a response back from the API. And the first thing I'm going to do with that response is call login success and send the user data as a payload. 2 other things are going to happen here. I'm going to take the token and the user ID, and I'm going to save them in session storage. The reason I save them in session storage is because I need them for all my API requests. I need to send the token in the header, and I need to send the user ID because I've connected the user to specific resources and subjects. I only want the resources that that user has access to. So if we go into subject actions, for example, and we try to get subjects, we're going to get the token and the user ID, put the token into the authorization header, and send it with the user ID as the endpoint so that we can get all the subjects that that user created. So that's why we store it in session storage. Another way I use session storage in this is to persist Redux state on refresh. So basically, you're logged in, you're doing great, you've got your user info, you've got your token and your user ID in session storage, and then you hit the refresh button. And all of a sudden, you're logged out. What's going on? So one way I found to get around this was I wrote 2 functions that basically saves the Redux store to session storage and gets the saved store from session storage. Anything in session or local storage is in JSON format. So first you need to stringify state, and then when you get it, you need to parse it. If there is state stored in session storage, that's going to become the state. So basically here you see either root reducer, or if there's persisted state, that's going to be the initial state. So that's a lot more I had to tackle on the front end. User login, keeping the user logged in, accessing the right endpoints, and storing and sending the things that I needed to send and store. There's a lot of complexity that goes into it. But I got it working.